Selamat sejahtera kepada penyeras dan pemeriksa. Nama saya Chen Li Yang, matric number S48447. Today I will talking about the investigation of Vertigo 2-person zero-sum game. The first one is about history of game theory. In 1713, the main identified investigation about the two-person game in mathematical game theory by James Verdegraaff. He wrote the letter about minimax strategy result to a two-person translation of the card game letter, and the issue is recently identified as Verdegraaff issue. Verdegraaff result is a minimax strategy equilibrium, but he create no spread of its solution to different game and describe in the rest that a strategy does not seem to be in the usual rules of plays of games of probability. The next leg is about types of game theory. The first one is symmetric or asymmetric. The second one is simultaneous or sequential. And the third one is cooperative or non-cooperative. Next slide is about my objective of study in FYP. The first one is to investigate the relationship between fuzzy and two-person non-cooperative game. The example is zero-sum game. And the second one is to study the concept of single objective two-person zero-sum game with fuzzy goal. Next slide is about literature review of my research. The first one is in 1999, the link says about the non-cooperative game theory concentrate on strategy option giving from interaction among competing participants. Every participant pick its strategy independently for improving its own benefit. The second one is in 2007, Wingmore says that zero-sum game is a mathematical statement of a condition in which a participant win or loss of benefit is correctly balanced by the loss or wins of the benefit of the other participant. If the total wins of the participant are added up and the total loss are subtracted, finally they will sum to zero. Thus, is called a zero-sum game. The next one is Jada in 1965 state that a fuzzy set is a group of goals with a continuous rate of membership. Just a step is represented by a membership function which distributes to every goal of the group of membership limiting between 0 and 1. And the last one is Sakawa and Nishizaki in 1995 have reflect the maximum result in two-person zero-sum game with multiple Vertigo and fuzzy payoff. Next slide is methodology of my research. Let the two players in two-person games be denoted by player A and B. The definition one is about the zero-sum game. Let I equal to 1 to m and j equal to 1 to n be set of pure strategy of player A and B respectively, and let f1 and f2 be payoff function of player A and B. When player A chooses a pure strategy, C belongs to I, and players B choose a pure strategy, D belongs to J. F1 CD and F2 CD are payoff of player A and B respectively. Then, a game is said to be zero-sum if and only if the payoff function satisfies F1 CD plus F2 CD equal to 0, all of C belongs to I, and all of D belongs to J. Next one, the definition is talking about the minimax theorem. For a two-person zero-sum game, H, it follows that maximum S belongs to S, minimum Y belongs to Y, SHY equal to minimum Y belongs to Y, maximum S belongs to S, SHY. Then a pair of strategy S star, Y star satisfying the above equation is called an equilibrium solution. And the next one definition is talking about the fatigue. Let a domain of the P payoff for player A be D P belongs to R, then the fatigue mu P with respect to the P payoff for player A is a fuzzy set on the set dP characterized by a membership function mu p ratio dP to 0 to 1. Next one is a result of fuzzy goal. Single objective 2-person zero-sum matrix game with fuzzy goal. Let H belongs to R M cross N be a payoff matrix and S M equal to S belongs to Rm. Summation C equal to 1 to M. SC equal to 1, where SC greater than or equal to 0. All of C equal to 1 to M. And Sn equal to S belongs to Rn. Summation of D equal to 1 to N. Sd equal to 1, where Sd greater than or equal to 0. All of D equal to 1 to N. Be the strategy space for player A and player B respectively. Let V0 and W0 be aspiration level for player A and player B respectively, and P0 and Q0 be the tolerance for player A and player B respectively. Then the 2-person zero-sum matrix game with fatigue is denoted by Fg and is defined as this equation, where greater than or less than is essentially greater less or less than or equal to sign. Next one is about the solution of the fuzzy matrix game. An order pair SY is said to be a solution of the 2-person zero-sum matrix game with fuzzy if S transpose HY greater equal to P0 V0 for all Y belongs to Sn, and S transpose HY smaller than or equal to Q0 W0 for all S belongs to Sm. Next one is about conversion of fuzzy matrix game and to fuzzy linear programming. The first one is find S belongs to Rm such that S transpose Hy greater equal to P0 V0 for all Y belongs to Sn. Summation of C equal to 1 to M, Sc equal to 1, where S greater equal to 0. The second one is find Y belongs to Rn such that S transpose Hy smaller than or equal to Q0 W0 for all S belongs to Sm. And summation of D equal to 1 to N, Yd equal to 1, where Y greater equal to 0. Next one is let Hd where D equal to 1 until N, and Hc where C equal to 1 to M denote the D column and C row of the matrix H respectively. Then the third one will be find S belongs to Rm such that HD transpose S greater equal to P0 V0, where all of D equal to 1 to N, and summation of C equal to 1 to M, SC equal to 1, where S greater equal to 0. Then the fourth one will be find Y belongs to Rn, shows that HCY smaller than or equal to Q0, W0, where all of C equal to 1 to M, and summation of D equal to 1 to N, YD equal to 1, where Y greater equal to 0. Then, the membership function for D constraint of the third one is given as mu D HD transpose S equal to when equal to 0 when HD transpose S smaller equal to V0 minus P0 and 1 minus V0 minus HD transpose S divided by P0 if V0 minus P0 smaller equal to HD transpose S smaller than V0 and 1 when HD transpose S greater equal to P0. And the membership function of C constraint for fourth step is given as mu C HCY equal to 0 when HCY greater than W0 plus Q0 and 1 minus HCY minus W0 divided by Q0 if W0 smaller than HCY and smaller than or equal to W0 plus Q0, and the last one is equal to 1 when HCY smaller than or equal to W0. Then the fuzzy linear programming FP3 and FP4 become fuzzy linear family maximum lambda subject to HD transpose S greater than or equal to V0 minus 1 minus lambda times P0, where all of D equal to 1 to N. Then the summation of C equal to 1 to M, SC equal to 1, when lambda is 0 to 1 and S is greater than or equal to 0. Then the next one is fuzzy linear duality maximum N subject to HCY smaller than or equal to W0 plus 1 minus N times Q0 when all of C equal to 1 to M. Then the summation of D equal to 1 to N, YD equal to 1 when N is 0 to 1 and Y is greater than or equal to 0. Then finally, we have the SY is a pair of equilibrium solution of the game model if and only if SY lambda is an optimal solution of the problem. Then the next slide is about conclusion of the research. For the past few years, the concept of single objective two-person zero-sum games with Vertigo has gained attention in the area of game theory. It has been used as a powerful analytical tool for just decision-making problem of the organization or competitive system. The study of Vertigo two-person zero-sum game has been done and the objectives for this study are achieved. Besides, the concept of single objective two-person zero-sum game with Vertigo is discussed, and the relationship between fuzzy and two-person non-cooperative game or zero-sum game are investigated. The research of Fajigo 2% zero-sum game is still open for further study. Thank you for your listening.